discussing mutual and non-mutual exclusive events in probability. First, we will be defining what is mutually exclusive events. Mutually exclusive event, it is a situation that only one event can take place at a time. Example, when tossing a coin, the result will only be head or tail, but not both when happened in a single toss. The formula can be expressed as P plus open parenthesis A or B equals P plus open parenthesis A plus P plus open parenthesis B, where P, A and B is the probability of A or B happening when A and B are not mutually exclusive. PA is a probability of A happening. PB is a probability of B happening. P open and close parenthesis A and B is a probability of A and B happening together. Non-mutually exclusive events, on the other hand, is a situation that two or more events can occur at the same time. The equation can be expressed as P plus open parenthesis A or B equals to P plus open parenthesis A plus P plus open parenthesis B minus P close open parenthesis A and B. Example, if a dice is rolled once, what is the probability of 4 and 1 turning up? Example, if a dice is rolled once, what is the probability of 4 and 1 turning up? So the solution will be, if you could still remember, we need to find the sample space. Here, sample space is 6 because the dice has 6 faces. So here, let A be the event of getting a 4. Thus, NA is equals to 1. Thus, utilizing our formula, PA is equals to NA over NS. Our NA is equals to 1 and our sample space is 6. Therefore, the value will be 1/6. Since two events are mutually exclusive and it can be expressed as P, A or B is equals to PA plus PB. So, PA or B is equals to 1/6 because if we will roll a dice, the probability of getting 4 is 1 over 6. And also, when the dice is rolled again, the probability of having 1 is 1 and the sample space is 6. Therefore, we can get 1/6 for the 4 and 1/6 for the 1 is equals to 2 over 6 or 1/3 or 33.33% of the probability. Another example, a card is drawn from an ordinary deck of 52 cards. Find the probability of getting number 1, queen or a king. Number 2, a king or a face card. 3, a heart or an ace. So first, we will try to solve for number 1, which is queen or a king. So let A be the event of getting a queen. In a deck of cards, there are 4 queens. The clover, the spade, the diamond, and the heart. So therefore, NA is equals to 4. And let B be the event of getting a king. And the same with the queen. There are 4 kings and a deck of cards. So the events A or B are mutually exclusive since they cannot occur at the same time. So our equation will be P, A or B is equals to PA plus PB. Substitute into NA over NS, that is for the queen, plus NB over NS, that's for the king. So our NA for the probability A is 4 and our sample space is 52 because we have 52 cards in an ordinary deck. So therefore, our sample space will be 52. The same with the probability of B. There are 4 kings divided by 52 equals 4 plus 4, 8, 52 as the denominator. So the probability of A or B will be 8 over 13 or 61.53%. Then, to solve for number 2, a king or a face card, let's see be an event of getting a face card. Face cards are composed of 4 kings, 4 queens, and 4 jacks. So, the NC is equals to 12. The 2 events B and C are not mutually exclusive since king is also a face card. Remember, we are dealing with number 2, a king or a face card, which means if we need to find the king and we will need to find the face card, they are not mutually exclusive because there is a tendency that we can draw king on this face card because king is also considered as face card. So thus, N, B, and C is equals to 4. Since they are not, B and C are not mutually exclusive, we will use the formula P close open parenthesis B or C equals P B plus P C minus P close open parenthesis B and C. Thus, our equation will be look like this. PB or C is equals to, since B, the king, has 4 kings in a deck of cards divided by 52 plus PC, which is NC over NS. C has 12 face cards divided by 52 minus the common between B and C, which is 4. So therefore, 4 divided by 52 equals to 4 over 52 plus 12 over 52 minus 4 over 52. We simply crush it out because they are similar. So our value that will be left will be 12 over 52. So our result on the P close open parenthesis B or C is equals to 3 over 12 or 2.78% probability. Next, for finding number 3, a heart or an ace, let D be an event of getting a heart card. Thus, D is equals to 13 because there are 13 characters found in an ordinary deck of cards which has the symbol of heart. So let E be an event of getting an ace. Then E is equals to 4 because there are only 4 aces that can be found in an ordinary deck of cards. Event D and E are not mutually exclusive events since they both occur at the same time. That is, in the heart card, there is one ace. Hence, probability of D and E is equals to 1. Thus, our equation will be like this. P plus open parenthesis D or E equals P D plus PA minus P plus open parenthesis D and E. So our equation, again, substitute all the values. P plus open parenthesis D or E equals to, since D has this value of 13 over 52 because we have D stands for the event of getting a heart card, which is all in all there are 13 heart symbols in an ordinary deck of cards divided by 52 plus 4 divided by 52. This is for the value of PE, which is the event of ace, minus P close open parenthesis D and E. This is the common because they are not mutually exclusive event, in which in a heart cards there will be one ace. So the value for P, D, and E is 1. So minus 1 divided by 52. So therefore, 17, we will have to add 13 plus 4, we have 17, and carry over the denominator, minus 1 over 52. So our result will be 16 over 52. Since both of them are divisible by 4, we will have to trim down into smaller number. So 16 divided by 4, that is 4. 52 divided by 4, that will be 13. Or the result for our P, D, or E is equals to 30.77%.